Dear students, today we are going to discuss the concept derivatives of an inverse function in the topic differentiation. Okay, in earlier standard you have studied the existence of inverse function. That is, inverse function exists if given function is 1 1 and onto. If someone wants to get more clear idea about 1 1 and onto functions and existence of inverse of function, I will share a link of my lecture about it. Okay, but today we will discuss the derivatives of an inverse function. So let's begin. So just by one example I will explain the concept of derivatives of an inverse function. Okay, so suppose if you take y is equal to f of x is equal to x square is 1 1 and onto function in its domain. Okay, suppose this function is given to you. Normally we take the y is equal to f of x as a function. So here y is equal to f of x is equal to x square. It's suppose 1 1 and onto function in its domain, because the domain is important. Whenever you want to define any function, then the domain is important, and on that domain, suppose this function, that is x square, is 1 1 and onto, then you will get the inverse function. Now see, how will you get the inverse? Then its inverse function is x is equal to f inverse y. See here it is y is equal to x square is the given function. Then how will you get the inverse of it? We have to write x is equal to, that is f inverse y, that is here it is equal to root y. Okay, so see, if y is equal to f of x is the given function, then x is equal to f inverse y, f inverse of y is its inverse. So here in this case, if it is y is equal to x square, then inverse is x is equal to root y. Okay, now we will discuss the relation between the derivative of the given function and the derivative of inverse function. Okay, so see here. Now for y is equal to f of x, that is equal to x square, what will be the derivative? First of all, here we have to find out the derivative of y with respect to x. So that is, all of you know that dy by dx is equal to 2x. So derivative of x square is 2x, that is with respect to x, remember. Now we know the inverse function, that is x is equal to f inverse y, that is root y, means x is equal to root y is the function. So how will you differentiate this function? We have to differentiate this function with respect to y. Okay, because x is depends on y, x depends on y. So we have to find out dx by dy, that is 1 upon 2 root y. Okay, so see here, this is the derivative with respect to x, which is 2x, and this is the derivative which is with respect to y, and it is 1 upon 2 root y. Okay, so see carefully, dy by dx, and this is dx by dy. Now we will find out the relation between them. So for that, see, if we compare the derivatives of both functions, as both functions means the original function and then its inverse function. Okay, so see here, how will you compare that? So what we have given here, dx by dy is equal to 1 upon 2 root y. Okay, now see the further step. So that is equal to 1 upon 1 upon 2x, since x is equal to root y. See here, x is equal to root y. So just we replace this root y as x. So 1 upon 2x. Now what is 2x? 2x is dy by dx. So next step is we get 1 upon dy by dx. So what we have get? Hence we get See, dx by dy is equal to 1 upon dy by dx, where dy by dx not equal to 0. So this is the relation between the derivative of given function and the derivative of its inverse. See here, dx by dy is the derivative of inverse function. See here, dx by dy is the derivative of inverse function. Okay, and dy by dx is the derivative of the given function, that is y is equal to f of x. So this is the relation, dx by dy is equal to 1 upon dy by dx, where dy by dx is not equal to 0. In another form, how will you express that? That is f inverse dash y is equal to 1 upon f dash x. F dash x means derivative of f with respect to x, and here f inverse dash y is the derivative of inverse function with respect to y. Okay, so this is the relation. By one example I have explained this relation. Okay, now actually this is a theorem that we have to prove here now, that is dx by dy is equal to 1 upon dy by dx. So see the theorem. See what is given here. Statement: if y is equal to f of x is differentiable function of x and inverse function x is equal to f inverse y exists, then what we have to prove? X is equal to f inverse y is also differentiable function of y such that dx by dy is equal to 1 upon dy by dx, where dy by dx not equal to 0. By one example just we have explained this relation, but now theoretically we have to prove this result. Okay, see here the function is given y is equal to f of x and it is differentiable function with respect to x. So this is the given condition, that y is equal to f of x is a differentiable function of x. In short, what do you mean by differentiable function? Means we get the derivative of this function, means we get dy by dx. Okay, in short. And see what is given here, inverse function x is equal to f inverse y exists. It exists because this is 1 1 and on 2 function, that's why it is given that the inverse function suppose exists. Then what we have to prove? We have to prove that x is equal to f inverse y, this is the inverse function, is also differentiable function of y. Now means we have to find out dx by dy such that, see here, dx by dy is equal to 1 upon dy by dx. Now theoretically we will prove this result. So see the proof. Now by Leibniz notations we will prove this result. Okay, you know about Leibniz notations, means first principle of the derivative by Leibniz notation. Okay, in our last lecture we have seen that concept of Leibniz notation. Okay, now see, for that first of all we will consider that let delta x delta y be the increments in x and y respectively. Okay, so here there are two variables x and y, so we will consider delta x delta y be the increments in x and y respectively. Now consider, see here, delta y upon delta x into delta x upon delta y is equal to 1. We know this, delta y upon delta x into delta x upon delta y is equal to 1. This is very simple concept. Okay, so that is, if you write like this, delta x upon delta y is equal to 1 upon delta y upon delta x. Okay, just after this step we have written like this. Now just take the limit delta x tends to 0 on both sides. Just by considering this we write this, and after that we have to take the limit delta x tends to 0 on both sides. Means if you take the limit on this if you take the limit on this step, then it will converts to the first principle of the derivative. See again, see that Leibniz notations. Okay, so by which you will get clear idea about this. So just you take the limit delta x tends to 0 on both sides, then what will you get? You will get this step, that is limit delta x tends to 0, delta x upon delta y is equal to, we get 1 upon limit delta x tends to 0, delta y upon delta x. Okay, see this step carefully. Now see, this is the first principle of derivative, this is also first principle of the derivative by Leibniz notation. Now just we will change here that as delta x tends to 0, delta y also tends to 0. Why this is possible? Because y depends on x. See, original function is y is equal to f of x. It says that y depends on x. Means if you consider that delta x tends to 0, that implies delta y also tends to 0. So here in this case we have to change this limit as delta y tends to 0. So rewrite the same step as like this, limit delta y tends to 0, delta x upon delta y is equal to 1 upon here limit delta x tends to 0, delta y upon delta x. See, here you keep as it is, but change here because of that Leibniz notation. Here denominator is delta y. Okay, so we have to take the limit on delta y. So delta y tends to 0 because as delta x tends to 0, delta y also tends to 0. Okay, so this is very important step. Okay, so this is the first principle of the derivative, and this is also first principle of derivative. Again and again I am telling you. See, this is the Leibniz notation, this is by Leibniz notation. So see, this is equation number 1. Okay, now we will see the next step, what we have to consider or what is given to you first of all after this equation. Now see what is given to you. Now given that y is equal to f of x is differentiable function of x. See, this is very important step that is given to you, that y is equal to f of x is differentiable function of x. Then by first principle of the derivative we have to write that limit delta x tends to 0, delta y upon delta x exists. So this given condition shows the existence of this limit. By Leibniz notation, this is a first principle of the derivative. So this limit exists, and suppose if the limit exists, then it must be finite. So that's why say it is dy by dx. So in that equation number 1 we will write dy by dx in place of this limit. So see what will you get. So equation number 1 becomes, see, left hand side of equation number 1 remains as it is, and it is equal to 1 upon dy by dx. So just by given condition show the existence of this limit and say it is dy by dx. Okay, just replacement here, you replace that limit as dy by dx. Okay, so now see, this is the limit, and 1 upon dy by dx is a finite quantity. Okay, because dy by dx is it is a limit of this. Okay, so dy by dx is finite, 1 is finite, so it shows that this limit also exists. See here, this is the answer of this limit. Okay, so further we can write, hence after this step we can say that limit delta y tends to 0, delta x upon delta y also exists, and say it is dx by dy. So this step shows that the existence of this limit. So if the limit exists, then we have to consider one finite value say it is dx by dy. So hence we get dx by dy is equal to 1 upon dy by dx, where dy by dx not equal to 0. So what we get here, we get derivative of x with respect to y, it is equal to 1 upon dy by dx. See, this is dx by dy means derivative of x with respect to y. Now what is x? X is f inverse y. So dx by dy is nothing but the derivative of x is equal to f inverse y with respect to y. So we can say that x is equal to f inverse y is also differentiable function of y. Okay, so see this theorem carefully, hence the proof. See, only 2 or 3 steps that you have to remember here, and you will get the clear idea about this theorem. Okay, so we have proved that x is equal to f inverse y is also differentiable function of y, that is dx by dy is equal to 1 upon dy by dx. So this is the relation between the derivative of the given function and the derivative of its inverse function. Okay, now we will solve some examples related to exercise given in your textbook. Okay, so see the question here. Find the derivative of y is equal to f of x using the derivative of inverse function x is equal to f inverse y in the following. We will solve just one example in this lecture. Okay, so see one example. Suppose the function is given y is equal to root x. Now see the question carefully. Find the derivative of y is equal to f of x. Here y is equal to f of x means y is equal to root x. Using the derivative of inverse function x is equal to f inverse y in the following. Okay, see the question is simple, means if you just consider that if you want to find out the derivative of y is equal to f of x, read up to this step. Okay, see, find the derivative of y is equal to f of x, and just if you have given y is equal to root x, then what will be the answer? We get dy by dx is equal to 1 upon 2 root x. We know the derivative of root x is 1 upon 2 root x. So this is very simple, but the question is given that using the derivative of inverse function x is equal to f inverse y, we have to find out the derivative of the given function. Okay, otherwise this is very simple question, because we know the derivative of root x is 1 upon 2 root x. So final answer is obviously it is 1 upon 2 root x. But how will you use the derivative of inverse function to get the derivative of this function? That is important. So that's why we have to use that relation. Okay, so see the answer. Now first of all, what is given to you? Y is equal to root x. So this is y is equal to f of x, normal. Okay, now what will be the inverse of this? So inverse is x is equal to f inverse y. So now in this case, what will be the inverse of this? How will you get? X is equal to y square. See, y is equal to root x is the given function. Then we required x is equal to y square as inverse of it. Okay, see, y is equal to root x is original function. How will you prepare its inverse? Just like this, x is equal to y square. Okay, so this is very important, because if y is equal to f of x is the function, then x is equal to f inverse y is inverse. Okay, so see this carefully. Now first of all we have to take the derivative of this, because we have to find out the derivative of inverse function first and then the derivative of this. Okay, so as per the given question, first of all we will find out the derivative of this. So differentiate with respect to y, because x is equal to y square is the function, so we have to differentiate with respect to y. See, not differentiate with respect to x. Okay, here we have to differentiate with respect to y. So we get dx by dy is equal to 2y, because derivative of y square with respect to y is 2y. Okay, so this is the derivative of this inverse function. But what we required? We required dy by dx. What is dy by dx? It is the derivative of this function. Okay, so actually we required dy by dx, but first of all we get dx by dy. So how will you get that? Here we required the derivative of y is equal to root x with respect to x. So see, now we know that the relation, that is dx by dy is equal to 1 upon dy by dx. So see here, so dy by dx is equal to what? 1 upon dx by dy. Okay, see here, this is the original part. Dx by dy is equal to 1 upon dy by dx, but dy by dx is equal to 1 upon dx by dy. So see how will you get? So next step, dy by dx is equal to 1 upon 2y. Here see here, dx by dy is equal to 2y. So just put the value here. Now see, we get dy by dx, that is 1 upon 2y by this relation, but actually we require dy by dx in terms of x, because it is in terms of x, function is given in terms of x. Here we get the derivative, that is 1 upon 2y, but normally we require the derivative in terms of x. So how will you convert it? See here, it is dy by dx is equal to 1 upon 2 root x, because y is equal to root x. So this is our final answer. See here, so given function is y is equal to root x, just we want the derivative of it, that is dy by dx is 1 upon 2 root x, but by using the derivative of inverse function, that is important. Okay, otherwise this is very simple, directly also you will get the derivative, but as per the question you have to write the answer like this. Okay, see again, here we find out, first of all we find out inverse function, that is x is equal to y square, and then we differentiate it with respect to y. We get dx by dy is equal to 2y. Then as per that theorem, that is dx by dy is equal to 1 upon dy by dx, we get dy by dx as 1 upon 2y, and now then we convert that 1 upon 2y as 1 upon 2 root x. So remember this question. So in our next lecture we will solve some more examples related to this type of questions, okay, from your exercise. Okay, so see this carefully. Okay, thank you.